In today's class, we are going to see composition of functions. First is the definition of composition of function. Composition of function is defined as if f is a mapping from A to B and G is a mapping from B to C, where f and G are functions. Then the composition of f and G is denoted as G composite f, and G composite f of x is given by the relation G of f of x for every x in A. So this is the definition of a composition of functions, whereas f and g in this are two functions. F is a mapping from A to B and g is a mapping from B to C. Composition of these two functions is denoted as G composite f with respect to the function x, where g of f of x for every x is in A. So we will see problems under this. Example 1.19, we have to find f composite g and g composite f. To find this, we are given with the values of f of x as 2x plus 1 and g of x as x squared minus 2. With the help of this, we can find f composite g and g composite f. So we know by the definition of the composition of functions, f composite g can be written as f of g of x. So what we have to do is f of, we have the value g of x which is given in the question. We have to substitute g of x as x squared minus 2. Now in the next step, we have f of x function. Also we have an equation for f of x. So using this relation, we have to simplify f of x. So f of x given to us is 2x plus 1. In place of x, we have x squared minus 2. Similarly, we have to substitute x squared minus 2 in place of x. So this will become, according to the relation, as 2 into x squared minus 2 plus 1. So 2 into x squared minus 2 2s are 4 plus 1, 2x squared minus 3. So f composite g is 2x squared minus 3. Similarly, we can find g composite f. So if it is g composite of x, we can write the relation according to the definition of a composition function as g of f of x. So f of x is given as 2x plus 1. Now what we have to do is we have to use g of x for this relation. According to the question, g of x is given as x squared minus 2. Instead of x, we have 2x plus 1. So substituting 2x plus 1 in the place of x squared. So it will become 2x plus 1 whole squared minus 2. Next step, what we have to do is we have to expand this using the a plus b whole square formula. A plus b whole square is equals to a square plus b square plus 2ab. A value is 2x and b value is 1. Substituting it, so we will get 2x plus 1 whole square is equals to 2x square plus 1 square plus 2 into 2x into 1. So 2x square will become 4x squared plus 1 plus 2 2s are 4x. Substituting in this place, we will get it as 4x square plus 1 plus 4x minus 2. It will become 4x squared plus 4x minus 2 plus 1 will become minus 1. So in this problem itself, we can note that f composite g will not be equal to g composite f. So in generally f composite g will not be equal to g composite f for f and g functions, which means Generally we can say that composition of functions are not commutative. What is mean by commutative is, the commutative property is nothing but A dot B equals to B dot A. But in this composition of functions, two composition of functions are not equal. That is why we are mentioning that composition of two functions are not commutative. Next problem is, represent the function f of x. F of x is equals to square root of 2x square minus 5x plus 3 as a composition of two functions. We are given with f of x as a function. We have to express this as a composite of two functions. We will see how to do that. What will we do is, given f of x is equals to square root of 2x square minus 5x plus 3. The value within the square root will represent it as a function. That is, we will consider f2 of x as 2x squared minus 5x plus 3. And the outer layer of the function, we will consider it as another function. That is, I am going to express f1 of x as square root of all these value together. I am going to express it as x. Now let us see how we are going to represent f of x as a composition of two functions. So f of x is given as square root of 2x square minus 5x plus 3. So what we have considered in this problem is the term within the square root, we have considered it as f2 of x. Therefore, we will change it as square root of f2 of x. And what we have done, the other one is square root of any term x, we consider it as f1 of x. So this we can change it as f1 of, because f1 of x is root x, f1 of the square root within the term, if it is x over here x. So if it is f2 of x, we can write it as f2 of x. So f of x is equals to f1 of f2 of x. We have represented the function as the composition of two functions. In this problem, we are given with f of x as 3x minus 2, g of x as 2x plus k, and if f composite g is equals to g composite f. So we have to consider this relation as equal and we have to find the value of k. So to find the value of k, we are given with these three things. So first what will we do is, we will find f composite g. F composite g with respect to the function x, we can write it as f of g of x. So what we have to do, g of x value given as f of 2x plus k. Now we have to use f of x function. F of x function is 3x minus 2. In place of x, we have to substitute 2x plus k. So 3 into 2x plus k minus 2. So 3 2s are 6x plus 3k minus 2. F composite g, we got it as 6x plus 3k minus 2. Similarly, we will find g composite f. G composite f of x can be written as g of f of x. So g of f of x value is given as 3x minus 2. G of x function is 2x plus k. In place of x, we have to substitute 3x minus 2. So 2 into 3x minus 2 plus k. 6x minus 4 plus k. So g composite f we got as 6x minus 4 plus k. So according to the given question, f composite g is equal to g composite f. So f composite g equals to g composite f, 6x plus 3k minus 2, which is equals to 6x minus 4 plus k. 6x will get cancelled, because if we bring the 6x to the other side, it will become minus 6x. So we directly cancelled it. What will we do is, we will keep k terms one side and the constant terms other side. 3k, k if it comes to the other side, it will become minus k, minus 4, 2 2 if it goes to the other side, it will become plus 2. So 3k minus k is 2k, which is equals to minus 4 plus 2 is minus 2, k equals to minus 2 by 2, k equals to minus 1. So thus we found out the value of k. So in the next problem, example 1.22, we have to find the value of k. To find the value of k, we are given with the relation f composite f of k is equals to 5, and where f of k is given as 2k minus 1. So let us find the value of k. First we are given with f of k is equals to 2k minus 1. We will take this relation f composite f of k, which is equals to 5. This can be written as f of k, which is equals to 5. F of k value, according to the question, it is given as f of 2k minus 1. That is, we have substituted the value of f of k here, which is given in the question, equals to 5. Now for this also we have to use the same relation f of k, but instead of k we have 2k minus 1. So on the place of k we have to substitute as 2k minus 1. So this will become 2 into 2k minus 1 minus 1, which is equals to 5. I have used the relation here as f of k equals to 2k minus 1. So in place of k we have substituted this value 2k minus 1. We will simplify this. 2 into 2, 4k minus 2 minus 1, which is equals to 5. 4k minus 3, minus 2 minus 1 minus 3, which is equals to 5. Minus 3, if it goes to the other side, it will become plus 3. 5 plus 3, 4k equals to 8, k equals to 8 by 4, k equals to 2. Thus we found the value of k. Composition of three functions is defined as if f is a mapping from a to b and g is a mapping from b to c, h is a mapping from c to d. B, three functions. What are the three functions? F, g and h. Okay. Using composite functions. We already know the composition of two functions. We are going to use that. Using composition functions, f composite g and g composite h, we get two new functions like using these two, we are going to write the composition of three functions that can be written as f composite g, composite h, and the other one can be written as f composite g composite h. Both are one and the same, but the parenthesis means a lot in this relation. So in general, f composite g composite h will be equal to f composite g composite h, whereas in composition of two functions they are not equal. In composition of three functions the both sides are equal, whereas h functions. Composition functions, composition of functions are associative. What is mean by associative is a dot b dot c will be equal to a dot b dot c. So if we take three functions and the brackets are changed on both the side, but it will give the same value if we equate it. Similarly, composition of three functions, f composite g composite h will be always equal to f composite of g composite h. So next is example 1.23. f of x is given, g of x is given, h of x is given, and we need to prove that the composition of three functions are associative. Let us do one by one. First we will take the left hand side. Left hand side it is given as f composite, g composite, h. What we have to do is first we have to complete the portions within the bracket. So I will take g composite h of x is equals to g of h of x, where h of x value is given as 3x. Now what we have to do next step is we have to apply g of x function. G of x function where x value is 3x. So 1 minus 2 into 3x. Simplifying this we will get 1 minus 6x. So we got the value of g composite h as 1 minus 6x. Next we will move on to the third function, that is f composite of g composite of x. What we have to do is, now we have this value, that is f of 1 minus 6x, right? We have substituted this value 1 minus 6x, and now you people know what to do. We have to use the f of x value now. In place of x we have to substitute 1 minus 6x. So in f of x I am going to use 2 into 1 minus 6x plus 3, and simplifying this 2 into 1 2, 12x plus 3. 3 plus 2, 5 minus 12x. So we got the left hand side as 5 minus 12x. On the right hand side also we should get the same value, we will verify. And on the right hand side, f composite g composite h. As I already told you, we should complete the portion within the brackets first. So f composite g of x, which means f of g of x. So f of g of x value is 1 minus 2x. Now we have to use f of x value. In place of x we have to substitute 1 minus 2x. If we do so, we will get it as 2 into 1 minus 2x plus 3. 2 1 to 1, 2 minus 4x plus 3, 5 minus 4x. Now we will move on to the third function, f composite g composite h. We know value of this, therefore f composite g composite h of x. Now we will substitute the h of x. F composite g, h of x value is 3x. Now what we have to do is we have to use the function of f composite g. F composite g function is 5 minus 4x. So what we have to do, in place of x we have to substitute 3x. So 5 minus 4 into 3x. Therefore 5 minus 12x. So whereas left hand side and the right hand side are equal. Hence it is verified. In the next example we have to find the value of x, and we are given with the function g f of x is equals to f g of x, and we are given with the functions f of x and g of x. Let us find the value of x by using the given functions. So f of x is given as 3x plus 1, g of x is given as x plus 3. So first we will find g f of x and we will simplify. G f of x means g of f of x. So this is very simple. First what we have to do is g of f of, we have to complete this brackets first. What is the value of f of x given? 3x plus 1. We have substituted the value of f of x. Now again what we have to do is, now also we have to use the function f of x, but instead the value of x we have to substitute 3x plus 1 in the place of x. So the given, this will become g of 3 into 3x plus 1 plus 1. So we will simplify this, then we will move on to the g portion. G of 9x plus 3 plus 1, g of 9x plus 4. Now what we have is g of x function. What is the function of g of x? It is x plus 3. So instead of x we have 9x plus 4. We have to substitute. So this will become 9x plus 4 plus 3 9x plus 7. Similarly, we have to find f g g of x. So, f g g of x can be written as f of g of x. Okay. So, similar way what we have to now do is first we have to complete this portion. G of x is given as x plus 3 and again it is g of x. Therefore, in place of x we have to substitute x plus 3. So, f of x plus 3 plus 3. So, it will become f of x plus 6. Now, we have to use the function f of x. F of x is 3x plus 1. In place of x we have to substitute x plus 6. So, this will become 3 into x plus 6 plus 1. So, 3x plus 18 plus 1. So, 3x plus 19. Thus, we have found out both the values. We will substitute in this relation and we will simplify. We will get the value of x. So, given is g f of x is equals to f g g of x. So, g f of x we got it as 9x plus 7 and f g of x we got it as 3x plus 19. So, simplifying I will take x to the other side, it will become 9x minus 3x and 7 to the other side, it will become 19 minus 7, 9 minus 3 6x which is equals to 12. So, x is equals to 12 by 6, x is equals to 2. Next section is identifying graphs of linear, quadratic, cubic and reciprocal functions. So, first is linear function. How will be the graph of a linear function? Let us see that. And the linear function is defined as if f is a mapping from R to R, that is real number to another real number, defined by f of x is equals to mx plus c, where x is not equals to 0. Why we are specifying x is not equals to 0 means if we substitute 0 here, then it will become f of x is equals to c. F of x is equals to c is a constant function. Therefore, it is not possible. The value of x shouldn't be 0 in this equation. Is called a linear function. Now, the graph of the linear function is represented as a straight line. So, this is the representation of graph geometrically for a linear function. When f of x is equals to x, this is the representation of the graph which is a straight line, and when f of x is equals to minus x, this is the representation of a graph which is a straight line. Next is modulus, or it is also called as absolute valued functions. So, whereas this is defined as if f is a mapping from a real number to 0 comma infinity, because 0 is in the closed brackets and we do not know where it ends, therefore, it is in open brackets, it goes up to infinity, defined by f of x is equals to mod x. So this is the representation of a mod x, whereas this is x if it is x greater than or equal to 0 and minus x if x is less than 0. What is it is? Inside the modulus, if we take the negative values also, if it comes outside the modulus, it will become a positive value. That is the representation of a function. So if you see here itself, they have started it with 0 only. They haven't mentioned the negative value here. So which means if the negative values comes within the modulus, it will become positive value. We'll see with an example. F of minus 1 if it comes out the modulus, it will become plus 1. F of 1 also modulus 1, which is also 1. So it is the same value. If it comes out of the modulus, it will become plus value. And the representation of a graph for a modulus function is represented as so if we have such a graph, we call it as a modulus or absolute valued functions.
Absolute value.
So next, the third one is quadratic equation, that is quadratic function. If f is a mapping from a real number to another real number, which is defined by f of x is equals to ax square plus bx plus c. In this relation, the a value should not be equals to 0. If it becomes 0, then the remaining relation will be f of x is equals to bx plus c, which will become a linear function, which is not possible. So a value in this shouldn't be equal to 0, is called as a quadratic function. And the representation of a graph for a quadratic equation is so this is the representation of a graph for a quadratic equation when f of x is equals to x square. Once the value of, that is the power of x, exceeds 1, it will become a curve. When the power of x is 1, that is f of x is equals to x, it will be a straight line. Once the power of x exceeds 1, this will become a curve. So this is the representation of graph for f of x is equals to x square. When f of x is equals to minus x square, the curve will face downwards. Next is cubic equation. If f is a mapping from a real number to another real number and f of x is defined as ax cube plus bx square plus cx plus d. In this relation, a shouldn't be equals to 0. Why it is? If a becomes 0, this will become a quadratic equation. So a shouldn't be equal to 0 in the cubic equation, where f of x is given as x cube, and the representation of a graph for a cubic equation is so this is the cubic equation is represented in such a way. Next is reciprocal functions. If f is a mapping from real number but it doesn't include 0 to another real number, defined by f of x is equals to 1 by x, because as we have mentioned it here, the 0 is not included while taking the real numbers. Why it is so? If we take 0, f of 0 will become 1 by 0. Anything divided by 0 will give us infinity. So in a reciprocal equation, whereas in a real number 0 is not included. Curve of a reciprocal equation is represented as such. Next is constant functions. A function f is a mapping from a real number to another real number defined by f of x equals to c. While seeing types of functions itself, we saw that f of x equals to c represents the constant function because all the elements in A will be mapped to the same image in B. So this is called as a constant functions. X is the real. For every x in R is called constant functions. The graph of a constant function is represented as x2. Yes, so all the elements in the set X will be mapped to the same image in Y. This is a constant function and this is the representation of a graph for constant functions.